Bright Tuty. Every student matters.
Hello students, this is the fourth topic of your chapter and it is a very important topic. The aim of this topic is transfer of heat. Basically students, you have to understand that heat can be transferred from one body to another. For example, you have this one body, you are heating it, right? If you bring it near another body 2 you can say, if you bring it close, for example, this was a heated body and this was a normal temperature body, right? The heat will get transferred to this body and this body will also heat up. So this is basically transfer of heat, and this transfer of heat can be done in 3 different ways that we will be studying. First of all, you have to understand that expansion also occurs when you heat a body. What is expansion? For example, basically if you are heating something, its volume increases, it expands. Why does this happen? If I give you an overview, this has to be explained to you in higher classes, but you can still understand. Basically in a solid, the particles are arranged very close to each other. First you have to understand that solids, liquids and gases, all of them are made up of particles. So what happens when you heat these solid articles or liquid articles? For example, this is a solid in which particles are arranged very close to each other. Then this is a liquid where particles are somewhat closer to each other but have some space. And then this comes gaseous, right? Gases have particles far away from each other. This is a solid, this is a liquid, and this is a gas. So what happens is when you heat any body up, when you are heating any body, the molecules get away from each other. They gain energy from the heat, and they start moving away from each other. So that is how a body expands when you provide it heat. If it is a liquid, the liquid will also expand. If it is a gas, the gas will also expand if you provide heat to it, right? Now, modes of transfer of heat. Basically, how does the heat get transferred? How do you transfer heat? There are 3 ways: conduction, convection and radiation. All these 3 are very, very important. For exam point of view as well, you must understand all the 3 because there are so many questions which can be made from this topic. The first mode of transfer of heat is conduction. In conduction, basically what happens is the process of transfer of heat from the hotter end to the colder end of a body is known as conduction. What is conduction? Conduction is the process in which heat from one point of a body reaches to the other point of the body. That is conduction. So what is happening? You are heating this iron rod. This is an activity which is a very easy activity and will make you understand the concept. For example, this is an iron rod and you are heating it. As you can see in the picture, there is a burner kept under the rod and you are heating it. So what happens is, firstly this end of the rod will get heated, right? Heat is present here. But if you keep on heating this rod, you will notice that this end, the end that you are holding, will also become hot. This end will also become hot. So what do you understand by this? What is happening? Basically, heat was conducted by this end of this body and it traveled towards the other end. Now this is conduction. The process of transfer of heat from the hotter end to the colder end of a body is known as conduction. Alright, so this is an example of conduction and the medium is the object itself. Right? Object is not moving at all. Object is at a standstill, but the heat is getting transferred from one point to another. Right? This is conduction. Now what are the conditions required for conduction? First of all is contact. There must be contact. Now in this example that we just saw, the particles of rod, as I told you, solids are also made up of particles. So there are numerous particles which are closely packed with each other. Now when heat reaches one particle and the other particle is also in contact with that particle, So that heat keeps on transferring to the neighboring particles. Right? It keeps on transferring. So that is how it is getting transferred, because there is contact between the particles. Similarly, if you have a heated body, or you can say you have heated a pan over the gas. Right? This is a pan. It is empty basically. There is nothing present inside this pan. And you have heated it over the gas. Right? Then you keep it on a steel plate. This is a steel plate. If you keep this heated pan over a steel plate, what will you notice? That this plate also becomes hot. Or you can even keep it over the pan. If you keep the plate over the pan, then also plate will get heated. This is because of the contact between the plate and the pan, and this is the process of conduction. Right? Now temperature difference. There must be a temperature difference between the two bodies. As you saw in the first activity, the first end was hot earlier and this end was cold. Right? There was a temperature difference, for example, after heating, if this end maybe came to 100 degrees Celsius, while this end is still at 35 degrees Celsius. Right? So due to this temperature difference, the heat traveled to this end. Right? For example, as I gave you this example of pan and a plate, the pan was, for example, at 150 degrees Celsius after heating, and the steel was at 25 degrees Celsius at room temperature. What happens then? There is a temperature difference, a major temperature difference, 150 degrees Celsius and 25 degrees Celsius. So due to this temperature difference, the heat gets transferred from one object to the another. Right? So first condition is contact. The second one is temperature difference.
To prove metals get heated by conduction. Materials required: iron ruler, brick, brass pins, Bunsen burner, candle wax. Method: take a flat iron ruler. On the foot ruler, fix 4 brass drawing pins with the help of wax. Place the ruler on the table and hold it in position by a brick. Heat the other end of ruler by means of a Bunsen burner. You observe that after a few minutes, first pin falls, then second, and so on. Conclusion: this experiment proves that heat energy travels from the hot end of ruler towards its cold end.
Now coming to the next concept, conductors and insulators. Right? So students, what are conductors? Conductors of heat are those materials that allow heat to travel through them. Basically, conductors are those materials that allow heat energy to be transferred. Right? I can write it down here. Materials that allow heat energy to be transferred through them. Alright, these are the substances which allow heat energy to pass through them. Now what are the examples? Firstly, consider table 1 only, this box that I have just marked. Consider only this box. In the first case, the conductors, the first one is given as steel. Students, steel is a good conductor of heat. We have utensils of steel because they are good conductors of heat. So when you cook food, they conduct heat and the food gets cooked. So that is why we use steel in our kitchens. And then iron. Iron is a very good conductor of heat again. These two are very good conductors. Generally, metals are good conductors of heat. Metals are good conductors. Now coming to insulators. Insulators are the materials, writing the definition, materials that do not allow heat energy to be transferred through them. Basically, these objects do not allow heat to be transferred through them. The first example is rubber. If you test any rubber object, the rubber object will not get heated as soon as you heat it over a burner or any heating substance. and then wool. Wool is basically wool traps air, right? Wool is able to keep us warm because wool is able to trap air inside it, and that air is a poor conductor of heat. So that is why wool is also considered as an insulator of heat, right? So these were some examples. Now coming to the table number 2, here you have to tell which substances are conductors and which ones are insulators. First example is copper. Now we know copper is a metal, and copper is a very good conductor of heat. So yes, it is a conductor. We will write C for conductors and I for insulators. Aluminium again is a metal. So for aluminium also we write C because aluminium also conducts heat. Aluminium is also used in utensils. Alright. Then coming to brass. Brass is an alloy. Basically it is a mixture of metals. So yes, it is also a conductor. As steel is also a conductor. Steel is an alloy as well, and iron is a metal. So all these are conductors. Now coming to the second row. Cotton is an insulator because again it traps air. Right? It is an insulator. Paper is an insulator. It is made up of wood. We obtain paper from wood, and this is an insulator. It does not allow heat to pass through. It burns as soon as we heat it. Right? Then plastic. Plastic is again an insulator. Plastic does not allow heat to be transferred through it. So plastic is again an insulator. Right? So these were the examples of conductors and insulators. Next thing is rate of conduction. We just noticed that heat can be transferred through conduction, right? Conduction is a mode of transfer of heat. So what happens if we talk about the rate of conduction of different substances? Basically, we have to tell that which substance will get heated faster as compared to the other substance, right? We are basically comparing two objects for their conduction power, right? So firstly you have to understand the activity apparatus. This is the activity. You do not have to perform this, you just have to understand, and this will make it more clearer to you. So what is the apparatus? There is a burner, there is a support system, right? And then we have metal balls. These can be of iron as well. Alright, metal balls, we have taken iron balls for example, and we have fixed them on a metal strip. This, in the first part we have, the first one has the metal strip of copper metal strip, and the second one has aluminium metal strip. So what is happening? Basically you have two metal strips, copper and aluminium, and you have fixed metal balls, iron you can say, on the strips with the help of wax. You have taken wax and you have used that wax to stick the metal balls on the strip of the metal, right? As you can see, these metal balls are still stuck. This basically is the picture of experiment as a result, right? So what happens is you start heating this end of both the strips. You start heating the ends. What happens? As you know that the heat will travel towards this end, and when you heat wax, the wax melts. Now we know that the metal balls were stuck on the copper strip because of that wax. The wax was acting as a fevicol, right? Now when you heat the copper strip, the metal balls come down, they fall down of the metal strip because the wax has melted down. As the wax has melted down, the metal balls come falling down, right? So in the first picture you see that 3 metal balls have come down and 3 are still on the rod, right? But in the second case you saw that only 1 metal ball has fallen down while 5 are still stuck on the metal strip. This tells us that copper conducts heat much better than aluminium because with the help of this activity we can say that copper strip is a much better conductor. Copper is a much better conductor of heat than aluminium. So this tells us the rate of conduction. Copper strip has a higher rate of conduction. You can say that copper strip has a higher rate of conduction than aluminium, right? So this basically made us clear that what is rate of conduction and how it varies in different substances. Now there is another activity for you to understand something, basically, right. So in this example, firstly, again I'll be explaining the apparatus. There is a burner. There is a wax cube wrapped in wire gauze. There is a wax cube wrapped in wire gauze, right? There is a wax cube. Now, there is air, right? Air above it, there is no other liquid or anything. There is only a wax cube. What is wax? You have taken wax and then you have taken wire gauze. Wire gauze is basically a net of wires, right? It is metallic wires ka net hota hai, and you have covered this wax cube with the help of this wire gauze, and you have put it inside the test tube, right? So what happens is you start heating it from the top. You are not heating from the bottom. You are only heating the top of the test tube. What happens is, as here only air is present, this air gets heated. This air gets heated. And as soon as the air gets heated, the cork that was stopping the mouth of the test tube flows out. What is happening here? The heat which was being transferred to the test tube never went down. It gave the heat to the air. It only supplied the heat to the air, and then the heat was so excessive that the cork was thrown out. So what does this tell you? That the air only gets heated and this air never travels down. It does not travel down. It only travels upward, and until and unless the cork is thrown out, the heat will be supplied to the air only. When the cork is out, the test tube will also become hot, and then the wax cube will melt. So what did you understand? When the burner was turned on the top of the test tube, the air present inside the test tube gets heated, and the cork that was stopping the mouth of the test tube is thrown out, right? Once the cork is thrown out, the hot air is blown away, and there is new air surrounding here. Now the heat travels to the bottom of the test tube first, and then the wax cube melts, right? Now practical applications of conductors. What are the practical applications of conductors? We have to study the practical applications of conductors. First of all, heat conductors are utilized in kitchen as utensils. Right? We need heat conductors for utensils, and there are many experiments for which we require heat conductors which allow heat to travel through them. There are many experiments in which we require conductors, and there are many in which we require insulators as well. But majorly, conductors are utilized in kitchen. Then thirdly, copper, aluminium. For utensils, we have steel and aluminium, silver. All these are very good conductors of heat and electricity as well. Copper is utilized to make electricity travel from one point to another, right? So these are some important uses of conductors. Now, practical applications of insulators. Now students, as I told you that utensils are made up of metals and they are used for cooking. So in the same utensil, if we take a pan, this part is of metal while this part is of some insulator. For example, plastic, right, or melamine. These are the substances which are used to make handles of the pans because they are insulators. They do not allow heat to pass through. Right? These are some plastic or any other substance which do not allow heat to pass through, so that your hand, when you hold this pan, your hand must not burn. If this is also made up of a conductor, your hand will feel the heat and you may get burns due to this. So major application is in our kitchens that we need insulators for our utensils. And secondly, in laboratories, We have different apparatus which is utilized to hold the hot substances or beakers or conical flasks, you can say, which have been heated during the experiment. To hold them, we require some insulators. There are many applications of insulators, including these, right? Now moving on to the second method of transfer of heat, that is convection. What is convection? In conduction, you saw that there was direct contact, but in convection, what happens is the process by which heat is transferred in liquids and gases by actual movement of molecules. This is only in case of liquids and gases. So what is happening? The heat is being transferred by the actual movement of molecules. As we know, in solids, the actual movement does not take place. So we are only discussing about liquids and gases. So what happens is, we will be understanding it with the help of an activity. For example, we are talking about convection in air. You light up a candle, right? Now if you put your hand above the candle, this is the candle and you put it above the flame, you will experience heat. But if you put your hand beside the flame, you will not experience that heat. Why is that so? This is because the heated air molecules become lighter. As the heat is supplied from the candle, the air molecules present above the candle get heated and they become lighter. As they are heated, and they rise above. They start rising above, right? They do not move sidewards. They only move above. That is why the heat is experienced only by your hand which is above the flame. So what do we understand? That when you heat any molecules of liquid or air, the molecules start moving upwards. They become lighter and the molecules start moving upward. They basically start moving. So transfer of heat is happening due to the actual movement of particles, right? The particles which were here earlier, they rised upwards and they reached near your hands, and then that's how you experienced heat. So here actual movement of particles takes place, right? In case of water, you also can experience how can you do that? You have to take a conical flask, or you can say a round bottom flask, and you have to heat it over a burner, right? You have to put a piece of potassium permanganate at the bottom, and there is water. So when you heat, you will notice that the color of potassium permanganate, that is purple. Basically this is potassium permanganate and it is purple in color. When you put the crystal inside, it does not dissolve instantly. But when you heat it, the particles start moving in all directions and the solution becomes purple. The whole solution becomes purple. So what does this tell you? That as soon as you supplied heat to the solution, to the water basically, the water molecules started moving. They absorbed heat and they started moving, right? So due to that movement, the heat was transferred in all the directions inside the container. So this is how in liquids and gases heat is transferred, and this process is known as convection. This process is basically convection. Alright. So now we are going to talk about land breeze and sea breeze. Both of them are also related to convection. And what is convection? Convection is the transfer of heat due to the actual movement of particles. Basically, particles will actually move for the transfer of heat. So what happens in case of land breeze? What is breeze? Breeze is the air basically. It is the stream of air. Sometimes during summers we always say that there is a cool breeze nowadays. So that is because that air which is circulating, that is moving, is cold, right? So now let's see what is sea breeze. So for this you have to understand a small concept. What happens is, during the daytime, the sea, the water bodies get hot. During the daytime, our land system the land which is basically our grass fields, our lands, our houses, they all become hot very fast during the daytime, right? So what happens is the air that is present above the land, it becomes hot and it rises upwards. The air rises upwards, right? As it is rising, the air then moves from here towards the sea. It keeps on moving, and due to air, the flow of air, the air moves towards the sea. And to replace this warm air, the cool air above the sea, because sea does not get heated that easily. The sea takes time to get heated, but the land becomes heated easily. So the cool air which is present above the sea moves towards the warm land to replace this warm air which was present earlier here. Right? So what happens is this cool air comes towards the land, and this is known as sea breeze. What is this? The flow of air, cold air, from the sea to the land during the daytime is known as sea breeze. Right? What is happening? During the daytime, the land becomes hot and the air which is present above land rises upwards. Now when it rises, there is a vacuum created, right? Not exactly vacuum, but the air has risen upwards. Now to replace that air, the cool air from sea comes towards the land. And this cool air when comes towards the land, this movement of air is known as sea breeze. When the breeze comes from sea, we call it sea breeze, and this is again cool. Right? Now land breeze. This is just the opposite. Now it is night time. What happens is our land, basically it gets heated very fastly and it cools down very fastly as well. Now during night time the land becomes cool. It is now cold. The land is cold. So what happens is, but the sea is still warm. It does not lose its heat very fastly. So it is still warm and the air is rising upwards. The air above sea, which is still warm, is rising upwards. Now to replace this air which has risen upwards, the air from land moves towards the sea during the night time. And the warm air from sea comes towards the land. So it is just the opposite. Here the breeze that is coming, that is cool, is coming from the land. So we call it land breeze, and it is during the night time. So what is happening basically? During the night time, the land cools down fastly while the sea is still hot. Right? So the hot air above the sea rises upwards. To replace that air, the air from land, which is cool, moves towards the sea, and this movement of air, this flow of air is known as land breeze. Alright, so these were sea breeze and land breeze. Coming to the third method of transfer of heat, the third one is radiation. Now what is radiation? The transfer of heat energy from a hot body to a cold body directly without heating space between the two bodies is called radiation. What is happening? There is no heating space between two bodies. This is body 1 and this is body 2. There is no space, basically there is no medium. You do not require any medium, but the heat is getting transferred from body 1 to body 2 with the help of radiations. That is known as radiation. The transfer of heat energy from hot body to a cold body directly without heating space in between the two bodies is called radiation, and the energy so radiated is called radiation energy. The energy that is radiated is known as radiated energy. Basically this hot body is releasing energy towards the cold body. So this energy that is radiated is known as radiation energy, and this process is known as radiation. Right? The perfect example for this mode of transfer of heat is solar radiation. What is happening? The radiation does not require a medium, and we are going to prove this with this activity, with this basically fact. This is the sun, right? And this is our planet Earth. Now there is vacuum in between them, right? There is no medium, but sun produces heat radiations, right? Solar radiations, we call them solar radiations. Now the radiations from sun travel from the sun towards the earth without any medium and they are not in contact. So this energy that is being released from the sun will be known as radiation energy, and this process of transfer of heat from sun to earth will be known as radiation. Alright, so this is a perfect example of radiation. Now absorption or radiation of radiant heat. You have to understand that radiation energy is absorbed and radiated as well. Let us start. This is sun, right? You have taken two bodies basically, right? First one is a black tin can and the second one is a white tin can, right? You have taken two bodies. Now you have put thermometers on both of them. This is the thermometer. You have put thermometers on both of them and you have put them under sun. You have to keep them under the sun for about 30 minutes. And after 30 minutes, what you will notice is that the temperature of the black body is higher. For example, it is 40 degrees Celsius, while the temperature of the white body is still 30 degrees Celsius. Why is this? Because black body absorbs more and more heat. Black body absorbs more and more heat, while white body absorbs lesser heat. Now there is another fact that yes, you have noticed the temperature under sun. When you keep these bodies in a closed room now, after heating under the sun, you have brought them inside a room. There is no sun and this is the black body and this is the white body. When you notice the temperature after 10 minutes, the temperature of black body comes out to be 25 degrees Celsius, while the temperature of the white body is 20 degrees Celsius. So what does this tell you? The initial temperature of the black body was 40 degrees Celsius and for white body it was 30 degrees Celsius. So the temperature of the white body, you're right, 20 degrees Celsius, right? So the temperature of black body fell for 15 degrees Celsius in absence of sun, while the temperature of white body only fell for 10 degrees Celsius, right? From 30 to 20 degrees Celsius. So this is also a fact that black bodies or dark colored bodies release more heat as well. So they absorb more and they radiate more, right? Now, so this was basically the fourth topic of your chapter, and in this topic we talked about transfer of heat, different modes of transfer of heat. The first one was conduction, second was convection, and the third was radiation. So this was the fourth topic.